Security aspects. So we are going to see about the security issues on the internet. When using the internet, a user must ensure that the website is secure before giving personal information. So it is advisable to check the URL, that is a uniform resource locator, that is the address of the web page. The URL should begin with https:// and the web browser should show a closed padlock icon. This protocol is of a secure website due to the S in HTTP. So data security is about keeping data safe and affects anyone relying on a computer system. If the data on a computer system is damaged, lost or stolen, it can lead to disaster. So here is a diagram showing the URL where you can see here we have the closed padlock and the HTTPS. Both of them are present, so it means that the website is secure. Internet risk. Data is threatened by malicious software, hackers, or accidental damage, and there are a number of different securities risks which can be overcome or minimized if proper risk mitigation is set. Each security risk, together with its description, possible effects, and risk mitigation will be discussed. Virus. A computer virus is a program or program code that is created intentionally and replicates itself with the intention to damage the computer. Some effects that viruses can have on infected computers include annoying pop-up messages on the screen, clog up the computer so that it slows down and crashes a lot, delete important files or data, access personal data like password, bank details, or credit card numbers. The primary source of infection these days are email attachments followed by illegal software and infected files from the internet. The computer can be protected against virus by using up-to-date antivirus software. The antivirus software scans the computer disk looking for any viruses, which it then removes and alerts the user. There are free antivirus applications available. We have AVG, Avast, Microsoft Security Essentials, but there are also applications that you have to pay for, like Norton, McAfee, Sophos. The computer can also be protected against virus by avoiding the use of any programs of doubtful origin such as free software. Don't open emails attachments unless you have scanned them. Scanning all optical and removable disks before opening any files. Don't click links in the website that seems suspicious, such as sites offering prizes or free stuff. Backup files on a regular basis. This may not get rid of the virus, but if it deletes files, at least they can be recovered. Spyware and Key Logging software. A spyware key logging software is a software that gathers information by monitoring key presses on the user's keyboard. The information is then sent back to the person who sent the software. The spyware may be installed without your knowledge by downloading some shareware or other software that does seem to be something useful, for example a free game or utility. It gives access to all data entered using a keyboard on the user's computer. The software is able to install other spyware, reads cookies, data, and change a user's default web browser. Some spyware such as keyloggers may be installed by the owner of a shared computer with the intention to monitor users. Some precautions include using an anti-spyware software. Users should be alert and look out for clues that the keyboard activity is being monitored. Using a mouse to select characters from password rather than typing them in using a keyboard. Hacking. Hacking involves breaking codes and passwords to gain unauthorized entry to computer systems. A hacker is a person who breaks into a computer system to steal personal data without the owner's consent or knowledge. A hacker creates programs that can gain illegal access to a computer, which can lead to identity theft by stealing data like bank numbers, etc. Cause damage to files and data by deleting or changing them. Access sensitive information. Simply see if they are clever enough to beat the system's security. It is important to know that some companies actually employ hackers as a way of testing how secure their security is. Hacking is different from cracking, as cracking is where someone modifies a program source code to remove or disable features which are considered undesirable by the person cracking the software. This is usually done for a malicious purpose. Precautions against hacking. Never reveal your user ID, that is a user identification, and passwords. Blocking external access by disconnecting modems when not being used. Encrypt any sensitive information. Use of anti-hacking software. And place a firewall between your computer and any network. Firewall. A firewall can either be a software or hardware, and it is found between the user's computer and the network. It filters information in and out of the computer. A firewall monitors connections to and from your computer. It can block unwanted data, including hackers, from reaching your computer. If it spots something suspicious, it closes the connection or disconnects it. Most operating systems include a firewall, and it should be turned on by default. In fact, most computers' operating systems have a software firewall built in. For example, Windows, Linux, and macOS. So now we are going to see how a firewall works. As you can see, we have the home computer, we have the firewall, the internet, and the web server. As you can see, we have two arrows. The first one, it goes from the home computer to the web server, and the second one from the web server to the home computer. As you can see, both arrows, it goes through the firewall and through the internet. So what happens when the user is requesting for a particular information? So the user will request a web page. So it will go through the firewall and through the internet and reach the web server where the information is found. So when the web server finds the information, what will happen? It will say, here's the web file transfer you asked for. So it will go through the internet and through the firewall, and it will reach the home user. And so when it will reach the home user, it will say this was requested by the computer on the home network, deliver it. So this is a normal process how the firewall here works. Now we are going to see if you have information that you have not requested for. So what will happen? So first, again, it will request for a web page. So the user will request for a web page. It will go through the firewall, through the internet, and will go to the web server. So when the web server will reply to this request, as you can see, the hacker also will send in some information. So the web server will say, here's a web file transfer you asked for, and the hacker also will send another file that you have not requested for. So it goes through the internet, and when it reaches the firewall will check it. So if it was not a request made by the computer on the home network, what will the firewall do? It will drop it, and only the information that they have asked for will go through. So this was requested by a computer on the home network, deliver it. So as you can see, the information that has not been asked for has been dropped by the firewall. The firewall will perform the following tasks: examining the traffic between the user's computer and the network, checking whether incoming or outgoing data meets a given set of criteria. If the data fails the criteria, the firewall will block the traffic and will give the user a warning that there may be a security issue. Logging all incoming and outgoing traffic to allow later interrogation by the user. Criteria can be set to prevent access to certain undesirable sites. The firewall can keep a list of all undesirable IP addresses, helping to prevent viruses or hackers entering the user's computer, and warning the user if some software on their system is trying to access an external data source. The user is given the option of allowing it to go ahead or requesting that such access is denied. There are circumstances where the firewall can't prevent harmful traffic, such that when the user has disabled the firewall, individuals bypass their firewall, and carelessness or misconduct by individuals such as control of passwords. Encryption. Encryption is used primarily to protect data in case it has been hacked. It won't prevent hacking, but it makes the data meaningless unless the recipient has the necessary decryption tools. So the data has been encrypted. To encrypt data is to encode it in such a way that it is unreadable to anyone who does not know how to decode it. The data is then decoded at the receiving end by the user who knows the way to decrypt it. One method of encryption is the cipher algorithm. In this method, each letter of the alphabet is simply replaced by another letter in the alphabet that might be one or more letters positioned away. So here we are going to see how encryption works. This diagram, it shows, let's say, the normal way that data is being sent through the internet and when it goes to the web server. For example, the visitor will send an information, it will go to the web server, and from the web server it will be sent back to the visitor with the information that the visitor has requested. Now with encryption, the visitor will send the information. The information will be encrypted when it is sending it. When the web server receives the information, what it will do? It will decode the information and then read what the request is and process the request. After it has processed the request, it will send back the information that the visitor, the user, has requested. So when it sends back the request, what will happen? It will encrypt the data that is being sent, and when the visitor receives the data, what it will do? It will decode the data, and then the visitor will have access to whatever request he or she has made. In encryption, a cipher or cipher is the output from an encryption algorithm. This algorithm uses an encryption key to produce a message which appears meaningless unless the same key is applied to unlock the original message. The key is referred to as an encryption key or a decryption key, depending whether it is used to encrypt the message or to decrypt the message. When using a cipher, the original information is known as plain text and the encrypted form as ciphertext. The plain text is described as a text or normal representation of the data before it goes through an encryption algorithm. So here we are going to see the concept of plain text and ciphertext. As you can see, we have the sender and the receiver. So when the sender will send a message, what will happen? So before the message is being encrypted, it will be known as a plain text. So after encryption, the message will be known as a ciphertext. And then when it reaches the receiver, the message will be decrypted and again it will be converted into a plain text. So this is the concept. Before encryption, it is known as a plain text. When it has been encrypted, a ciphertext. And when it has been decrypted, it is known as a plain text again. Different keys are used to encrypt and decrypt messages. To encrypt the messages, the recipient's public key is used. And to decrypt messages, the recipient's private key is used. For example, encrypting using letters which are 5 positions away would change the original text computer into ciphertext. H, T, R, U, Z, Y, G, W. Let's encrypt the message, see you tomorrow at 3 p.m. So step 1, the sender encrypts the original message by using the recipient's public key and encryption software. Step 2, the encrypted message is, as you can see, the word C has become XGG. As you can see, it is unreadable, so it is sent to the receiver. Step 3, the receiver decrypts incoming message to recover the original message. See you tomorrow at 3 p.m. by using the private key and the decryption software. Phishing. Phishing is the act of trying to trick someone into giving out information over email. You might receive an email claiming to be from your bank or from a social networking site. They usually include a link to a fake website that looks identical to the real one. When you log in, it sends your username and password to someone who will use it to access your real accounts. They might steal your money or your identity. For example, the emails usually say that there is a problem with your account, and then they ask you to provide your username, password, or account numbers so that the problem can be rectified. Precautions against phishing. ISPs, that is Internet Service Providers, should filter out phishing emails. The user should be cautious when opening emails or attachments. Remember that your bank will never send you an email asking for your personal information or your username and password. Check that the web page you visit is a secure one. The web page must begin with https:// and a little closed padlock must be displayed on the status bar of the browser. Pharming. Pharming is the act of redirecting internet users to another site without their knowledge. The intention of pharming is the same as phishing, that is to obtain personal information such as username, password, and bank details, etc. It usually targets users of online banking or shopping websites. The way this is done, however, is slightly different. Pharmers infect legitimate websites with malicious code and will redirect you to that bogus fake version of the website. Pharming is a practice in which malicious code is installed on a personal computer or server, misdirecting users to fraudulent websites without their knowledge or consent. It affects the IP, that is the Internet Protocol address that a user is searching for. So here we are going to see how pharming works. On the right hand side, as you can see, we have the fake website. We have the original website, in the middle we have the user, and then we have the attacker and the DNS server. Many ask what is a DNS server. So a DNS server, DNS stands for Domain Name System. So a DNS server is a computer server that contains a database of public IP addresses and their associated host names, and in most cases serves to resolve or translate those IP addresses as requested. DNS server run a special software and communicate with each other using a special protocol. At its most basic, DNS is a directory of names that matches with numbers. The numbers in this case are IP addresses which computers use to communicate with each other. In simplified terms, think of DNS server like your smartphone contact list, which matches people's name with their phone number and email addresses. Then multiply that contact list by everyone else on the planet. How pharming works? The attacker will first infect the DNS server. So the attacker targets the DNS server used by the customer. So when the customer will want to go to the original website, what will happen? So the customer will type the website, as you can see for number 2 here. So the user's computer will query the DNS server for the IP address of www.cyberbank.com. Then the DNS server will look, as it is looking for the IP address, it will return back the IP address to the user. So as the DNS server has already been attacked, it will return the IP address of the fake website to the user. So what will happen next? The user will be fooled into visiting a fake website. So this is how pharming works. So once the attacker has managed to get the user to visit the fake website, there are many ways in which the user can be tricked into revealing his or her credential or giving out personal information such as the username, password, which are recorded and are used to take money from your real bank account. So here are some key points how pharming works. A hacker attacks a DNS server. The hacker redirects traffic from the real website to his own fraudulent site. The user types in the web address of the real site. They are instead taken to a fake site, usually a bank or other e-commerce site. It is very difficult to spot pharming attacks because to the user everything seems to be normal. But some common precautions are: check the URL web address of the website before you enter personal information. Make sure that you are on a secure website such as HTTPS or the closed padlock next to a website URL. Use an anti-pharming tool which is available for Windows-based servers, educating web users on pharming and its dangers. War driving. War driving is the act of locating and using wireless internet connections illegally. It only requires a laptop or any portable devices, a wireless network card, and an antenna to pick up wireless signals. War driving is the act of searching for Wi-Fi wireless network by a person in a moving vehicle, using a portable computer, smartphone, or personal digital assistant (PDF). It is possible to steal a user's internet time by downloading large files or movies. It is also possible to hack into the wireless network and steal a user's password and other personal details. So, internet user needs to protect their password from other users. If any unusual activity is seen, then the password should be changed. Precautions against war driving. Use of firewall to prevent outside users from gaining access. Use a wired equivalent privacy, web encryption. Protect use of wireless device by having complex passwords before the internet can be accessed. Cookies. A cookie is a small piece of data sent from a website and is stored in the user's web browser while the user is browsing. Every time the user loads the website, the browser sends the cookies back to the server to notify the user's previous activity. So cookies are generated each time the user visits the website. A message is frequently displayed saying cookies are required to access this site. Every time a user visits the website, cookies will have collected some key information about the user. They are able to carry out user tracking and also maintain user preferences. For example, Amazon.com uses cookies to help identify a user when revisiting the site. The website reads the cookie and can then look up details such as username, address, credit card numbers from their database. This saves users from having to re-enter your data every time you visit. So here are some key points. The information gathered by cookies form an anonymous user profile and does not contain personal information such as credit card numbers or passwords. Because of the information they do collect, however, they are subject to privacy and security concerns.